Hello students, this is Miss Medina, and today we're going to talk about multiplying polynomials. And we're going to focus on the area model, though FOIL is still acceptable, and technically FOIL is the area model. But here we go. Remember the area model, that's when we make the grid, right? Through, or depending on how many you have, right? So adding and subtracting and multiplying polynomials, it's a system that's analogous to the integers. Analogous just means that it's very similar to the integers when we add, subtract, and multiply numbers. Remember, integers are your negatives, 0, and your positives, whole numbers, right? No fractions, and that they're closed under these operations. So you multiply two polynomials, we're going to get a polynomial. All right, so here we go. In order to use the area model, you have to be able to tell the number of terms. I feel that a lot of us already have good practice. So here we have 4x times the quantity of x plus 3. And so when I look at the 4x, I see one term. And when I look at the x plus 3, I see two terms. So this is going to be a 1 by 2. So that means one row, two columns. Right? That's too small. My bad. I apologize. Here we go. So that's one row, two columns. All right, so the 4x is going to go here, and the column is going to go here, x, and the plus 3. And now we're going to multiply. All right, so to find the answer for this first box, it's 4x times x. Remember, when you add and subtract, you focus on the coefficients and the variables stay the same. The exponents stay the same. But when we multiply, we focus on both the coefficients and the exponents of the variables. So 4x times x is going to give us 4x squared. Why? Because this is a 1 and that's a 1, and this exponent plus that exponent at 2 makes. And why do we keep the 4? Because this is technically 4 times, let me change the color, see if that kind of helps a little bit. Right here, that's a 1. So 4 times 1 is 4, and then add the exponents. Multiply the coefficients, add the exponents. Let me write that down. Multiply coefficients, add exponents, and I'm going to put an if, add exponents. All right, so this is the first one, and that's the second. Add exponents if they are the same base. All right, so x is the base, the variable, and x, so they have the same base, so we add the exponents. All right, so that's going to give us 4x squared. All right, and then the next one, to get the answer for this second box, that's 4x times a positive 3. Okay, so we should be thinking like this, 4x times 3. Right, or wrapped in parentheses, 4x times 3. All right, the coefficients are the 4 and the 3, so that becomes 12. We're multiplying the coefficients, and we're going to add the exponents. Well, there's only one variable. So there you go, 12x. So now you look at what's inside the box. Out of these two boxes, are they like terms? No, this is x raised to the second power, and this is x raised to the first power. So they're not like terms. So your final answer is going to be 4x squared plus 12x. Highest degree to lowest degree, here we go. That's the answer. Let's do it again. I know, watch it, watch the explanation again for A if you want to, okay? Believe me, it'll be worth it. It'll become clearer if you watch it 2 times or 3 times. All right, this one. So when I look at B, okay, I see in parentheses the quantity of x minus 3 times the quantity of x plus 7. When I look at x minus 3, I see two terms. And when I look at x plus 7, that's also two terms. So we're going to do a 2 by 2 box. So that means 2 rows and 2 columns. Okay. Don't make fun of my boxes. Okay. So the 2 rows are going to be for the x and the negative 3. So x and then the minus 3. And then the x plus 7 are going to go here. X and a positive 7. And so now we multiply. For this box right here, we have to multiply the x and the x. So what's x times x? Same base at the x. You're like, oh, Miss Benita, do the rules really apply? Yes, they do. X times x is 1x times 1x. So now think about it. Multiply the coefficients. What's 1 times 1? 1. All right. Multiply the variables. Same base at the exponents. X times x, exponent of 1, exponent of 1, and once again, what's 1 plus 1 at the exponent? It will be 2, or just x squared. X times x is x squared. Okay. X times 7, oops, sorry, I forgot to write it down. It's going to be 7x. And so this one came from the x and the 7. Now, this one, okay, I don't know why I get all this color, but this one comes from the negative 3 and that x. So what's negative 3 times x is negative 3x squared. Oh, I'm so sorry. Negative 3x, okay? So, my bad. Got stuck reading that. See, there's only a single x. Negative 3 doesn't have an x, so it's just negative 3x. And then the last one, this one, is going to come from the negative 3 and the 7. So what's negative 3 times 7 is going to be negative 21, correct? All right, so now you want to look at your boxes, and you want to notice whether you have any like terms. And usually your like terms are going to be these two right here, right? Okay, negative 3x, 7x. All right, so once again, what have I taught you? Look at your coefficients. When you add and subtract, look at the coefficients, keep the variables the same. Repeat the mantra. When I add and subtract the coefficients, keep the variables the same. All right, so which coefficients do we see? You should see a negative 3, and you should see a positive 7. And when you combine these, you should get a positive 4. Clear? All right, put this on the side right here. All right, so we'll start with the yellow one, which is the x squared. Then negative 3x plus, you see the big plus sign right here in the middle? Plus the 7x is going to give us the plus 4x. And then the constant, negative 21. And look at that, it's already in standard form. So please watch this one again as well, as I'm going to start going a little bit faster in the other problems. And I want you to feel that, oh, she's going too fast. Clear? Watch the videos again until you feel comfortable. All right, first lesson. When you see x plus 5 quantity squared, or the quantity of x plus 5 squared, this literally means, write it out, x plus 5 times x plus 5. That's what squaring means. Something gets multiplied by itself. And they're both quantities. They both get their own box. So it's going to be 2 rows and 2 columns. And this is going to be hard to tell. What are we doing? X plus 5, X plus 5. And so these come from this one, and these come from that one. Clear? All right, we'll do the best that we can. Here we go. All right, so for this spot right here, right, that's going to be this x times that x. So x times x is going to be x squared. Right. For this spot right here, okay, that's going to be the x times the 5. So that's 5x. All right, for this spot right here, that's going to be the plus 5 and the x right here. So once again, 5x. Get rid of those arrows. And for this last spot right here, that's going to be the 5 times the 5. So that's going to be the 25. This digital pen. So that's 25. Positive 25. All right, so which ones are like terms? Like I told you, usually you're going to find your like terms here. That doesn't mean they can't appear somewhere else. Okay, and what's 5x plus 5x? Remember what I told you. Add the coefficients, keep the variables the same when you're adding and subtracting. So what do you see? You see a plus 5 and you see another plus 5, and together they make a plus 10. All right, so those two are going to be 10x together. 5x and 5x give us 10x. Add the coefficients, keep the variables the same. All right, so now we just collect the terms. So the answer is going to be x squared plus 10x plus 25. If you don't know where the 10x came from, just go ahead and rewind a little bit, 1 or 2 minutes, and you'll see the explanation again, okay? Okie dokie. Here's another problem. Quantity x minus 4, I see 2 terms, so that's 2 rows and 2 columns. So here we go, 2 rows, 2 columns. So it's going to look this. Slightly better box, right? All right, this one is going to go here, and this one is going to go here. All right, so I hope the coloring is helping. X minus 4. So the x goes here, and the negative 4 goes here. X plus 4, x goes here, and the positive 4 goes here. No, you don't need the positive sign, but you know, it's a teaching video. All right, once again, our first box right here is going to come from us multiplying x times x, so that's going to give us x squared, right? Our second box here is going to come from us multiplying x times 4, so that's going to give us 4x, right? This box over here is going to come from us multiplying the negative 4 and the x, right? Negative 4, and then you got to go to the green part, to the x. So this is going to give us, like I said, digital pens, negative 4x, and the last empty box is going to come by us multiplying the negative 4 and the positive 4. Negative times positive, it's negative 16. Okay, and where do we usually find our like terms? And yes, indeed, they are like terms. Are they always going to be there? No. Okay, no, no, no. They're not always going to be there. There's always going to be that one exception. So when I look at these two like terms, I see a negative 4x and a positive 4x. So that's going to give, oh wait, they cancel out. Gives us 0. So the middle terms disappear. They cancel each other out. So you're really only left with x squared minus 16. Okay? So that would be the final answer. All right. E. A little bit bigger numbers, but here we go nonetheless. 3x plus 6 is the first quantity, and I see two terms, so that's two rows. 2x minus 7, same thing, two terms, so this will be the two columns. I feel like we're in Rome. So start making your table. Once again, please don't skip the steps. And yes, I'm gonna have you do like a gazillion of these. And if you do them by hand correctly, then you'll train yourself to do them correctly. But if you cheat, then you won't learn how to do it, and it'll be a big problem, because then you won't pass the test, and then you'll have to explain to your parents why 3x plus 6. And like, Miss Medina can't explain, and then I'll show them the video, and they'll be like, Miss Medina can explain. You need to listen and follow instructions. All right, so 3x plus 6, and then the 2x minus 7, and so we start this one right here. The answer for here is going to come from the 3x times the 2x. Okay. So the 3 times the 2 is going to give us the 6. 3 times 2 is 6. X times x, we're multiplying, so same base at the exponents, x squared. All right, so now we'll focus on this box, and this one's going to come from the 3x times the negative 7, so that's going to be negative 21x. All right, so now we'll focus on this box, and that's going to come not from these, but from the positive 6 times the 2x. All right, so that's 12x. And the last box is going to come from the two constants, the positive 6 times the negative 7. And was that negative 42? Hope so. All right, so do you see any like terms? I think I do. Both of these have a single x, right? And what do we see? Once again, don't cheat yourself. Think carefully. This is a positive 12x and a negative 21x. So what's that? 8 and 1, negative 9? Oh my gosh, let me pause. Okay, so yes, it's going to give us negative 9x. And so combining your like terms, it's going to be 6x squared minus 9x minus 42. All right, so this is that one scenario where those two terms are not going to be alike. All right, so when you look at this, I see x minus 3 as the first quantity. Once again, 2 rows. 2x squared plus 2, that's 2 columns. Is it always going to be 2 by 2? No, but we have to start easy, not to scare you too much. Right, here we go. Hey, my grip on the pencil is getting better. Look at that. All right, so the x minus 3 is going to go here. The 2x squared plus 2 is going to go here. All right, x negative 3, 2x squared, and then positive 2. Oh, my neck. This looks like a long video, but we're almost done. I think this is the last example for this video. All right, the first box right here. Okay. So this one is going to come by multiplying x times 2x squared. All right, big lesson. X times 2x squared. Even if you think about it in parentheses. Technically, this is 1x times 2x squared. So the 1 and the 2 get multiplied, and the 3, the x and the x squared, same base at the exponents. What do you remember? I told you this is an understood one, so this is x cubed. Yes, x times x squared is x cubed. X times x to the 4th is x to the 5. You can't forget that this is a 1 and you need to add the exponents. All right, review lesson over. Right? I hope you wrote it down somewhere because you're supposed to remember that. Alright, so this is 2x cubed. Alright, so now for this one. For that one, we need to multiply the x times the 2. Oh, that's easy, 2x. Okay. Digital eraser. Alright, so for this one, that one we need to the negative 3 times the 2x squared. That's just negative 6x squared. Whoa, what do you mean, whoa? Negative 3 times 2x squared. Negative 3 times 2 is negative 6, and there's only x squared, so x squared. See? Miss Medina, those are not like terms. I know. This is an example of when you don't get like terms. All right, the last box is negative 3 times 2, and that's just regular negative 6. Now, do you see any like terms? No, because in the first box, we have an x to the 3rd power. Nobody else has x to the 3rd power. In this bottom box over here, I have negative 6x squared. Nobody else has an x squared. In this top right, 2x, this is just x to the 1st power. Nobody else. And the bottom is just a constant. So no, there are no like terms. So your final answer is just 2x cubed minus 6x squared. Why did I write that one next? Because remember, we have to write it in decreasing exponent order. And then plus 2x and then minus 6. This is not awkward. This is normal. This is your life now, algebra. Okay? Thank you.